Welcome to part two, and today we're talking about Venn diagrams and how they relate to prime factorization. So first we need to look at what a Venn diagram is, and we see one here with two overlapping circles. And Venn diagrams show relationships between sets of information. So I want to know, out of the list of items here, which things are food and which things are yellow things. So I'm going to go ahead and classify those. If you want to pause the video, you can go ahead and try to guess where the objects below are going to go. Noodles are definitely going in the food category. This flower is yellow. Pokemon ball is neither. Popcorn, lightning, neither. Lemon is food and yellow. Paintbrush, this is a yellow thing. Tella could be classified for food, I guess. Pac-Man is yellow. Hamburger and pizza. Okay, now that we've gone and classified these things, one of these objects appears in both circles, and that's the lemon, which is both a food and a yellow thing. So I'm going to go ahead and keep it there. Also cross it off on this side. So in our Venn diagram, we see that the relationship between the set of information of food and the set of information of yellow things is that there's a middle ground where a lemon is both a food and a yellow thing. We're now going to go forward and find the relationship between the prime factorization of 20 and 30 using the Venn diagram. The first step to doing this is actually to find the prime factorization of both those numbers. So using the tree method, we're going to find the prime factorization of 20 and 30 below. So go ahead and pause the video. Okay, welcome back. Hopefully you found that the prime factorization of 20 and 30 look like this. We can split 20 into 2 and 10. 2 is prime, so it's circled. 2 and 5 break up 10, so we can circle 2 and 5. 30 can be broken up by 5 and 6, and then again into 2 and 3, and these are all the prime factors of 30. Your trees may look different, but your answers should be 5, 2, and 3, and 2, 2, 5. So the first step is to go ahead and add those numbers to your circles. So we have a 2, we have a 2, and a 5. So going on 30, we can do the same thing and add 2, 3, and 5 to our circle here. Now we have some numbers that are common, so let's go ahead, just like the lemon example, and we can cross out this 2, cross out this 2, and add 2 here. Likewise, we have a common 5, so we can go ahead and cross out 5, cross out 5, and then add our 5. So from this diagram, we can see the relationship between the factors, and we're going to start with looking at the relationship between the LCM and how that pops up in our diagram. So the LCM is going to be the product of this area, which is our circle on the left, times our product of our middle area, times the prime factors of our third area on our right. So what that's going to look like is 2, because it's the only one left, times, I'm just going to use a dot, our middle area, which is 2 and 5, times our third area, which is a 3. So if we take 2 times 2 times 5 is 20, times 3 is going to be 60. So this Venn diagram can show the relationship between the LCM and the LCM of 20 and 30 using prime factorization Venn diagram is 60. This diagram is also helpful for finding our greatest common factor. And our greatest common factor is going to pop up in the middle. So the greatest common factor is going to be the product of whatever prime factors they have in common. So if we take 2 times 5, we're going to get a product of 10. And that's going to be our GCF, our greatest common factor of 20 and 30. So that's using prime factorization Venn diagram to find both the LCM and the greatest common factor of two numbers. So let's go ahead and try another one. All right, let's take a look at our second example. Using the numbers 24 and 36, find the LCM and the GCF using a Venn diagram. So go ahead and pause the video. All right, welcome back. And the first step, as you know, is to find the prime factorization using the tree method that we've learned of 24 and 36. So again, your trees can differ, but at the end, we will have the prime factors of 24 are 2, 2, 2, 3. And the prime factors of 36 are 3, 3, 2, 2. So the first step is to list those in our diagram. So after we've listed them in our diagram, we can look for similarities across. So we see that we have 1, 2 here that can match to this 2 here. And we can go ahead and add that 2 to our middle section. Similarly, we have another 2 here that corresponds to this 2 over here. Note that we do have a 2 left over here that doesn't pair to anything, so we can leave that one by itself. But we do have also a pairing of 3 on this side and 3 on this side, so they have a relationship, and we can write 3 in the middle. So using this information to decipher our LCM, we know that we can find the product of this area times this area multiplied by our circle on our right. So what that would look like would be 2 times 2 times 2 times 3, which is our blue area, times 3. And if we take 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. So our least common multiple of 24 and 36 is 72, which is a lot faster method than actually writing it out and finding all of the multiples of 24 and 36. Now, quickly to find the GCF, we can look at just the prime factors that they have in common, so this area in the middle, and we can find the product of these. So we take 2 times 2 is 4 times 3, and we have the greatest common factor of 12. So there it is. There's your second example. You are ready to go. You know how to find the LCM and GCF of any two numbers using a Venn diagram. Thanks for watching.